Good morning, good afternoon, and good evening. My name is Ahmad Fahmi with number 220553136. Going to the presentation about polymeric materials. Okay, so today I'm gonna do a presentation about 4.4 molecular weight of polymers, 4.5 definition of resin and plastic, 4.6 polymerization process, and 4.7 structural shape of polymer molecules. The first one is 4.4 molecular weight of polymers. The molecular weight commonly used in the characterization of a polydispersed polymer are height number average, weight average, and viscosity average molecular weight. Consider a sample of polydispersed polymer of total weight W, in which this one next. By the definition of molecular weight as weight of sample per mole, Mn W per n equal to sigma Ni Mi per n equals to sigma N1 Ni Mi. MW can be determined by measuring light scattering of dilute polymer solution. MW is always higher than Mn. The viscosity average molecular weight is defined by the equation mv sigma v wi mi equal to sigma Ni Mi per sigma Ni Mi. Polydispersity index, the ratio of weight average molecular weight to number average molecular weight, is called the dispersion of polydispersity index. It is a measure of length of molecular weight distribution curve, like figure 4.4, and is used as such for characterization purpose. 4.5 Definition of resin and plastic. Resin. The term resin originally referred to vegetable derived organ products of relative high molecular weight, the best known of which are rosin and balsam obtained from coniferous tree. It is often used interchangeably with the term plastic. So this is the process of making resin. The first step is put the resin into the tank so we can heat the resin until it's warm enough. Then we filter the resin that has been heated until it's clean. The next step is we put it through to the tank until it's boiled, to the condenser so we can extract the resin. This is the process of putting the boiled resin to the condenser so we can extract. The first one we get the water and oil. The first layer is water and the upper layer is the oil. This is the water and this is the oil. Next we process again. The final result is we call it as rosin. Plastic. Plastic is an adjective meaning. It is adjective defining a material that capable of being molded or shaped, with or without the application of heat. The term plastic is also used in classifying polymers and includes all polymers. Plastic are not considered to be elastomers, rubbers, and fibers.
Most of today's plastics are man-made and derived from fossil fuels. Crude oil and natural gas are primary sources as they provide a cheap alternative to plastic made from plants.
because we can
The
extract
first step in the
anything
production
from
of plastic
water,
is the extraction
including
of crude
plastic.
oil and natural gas from the ground.
So we
From
extract
there, the
crude
fossil
oil
fuels are
or
sent to
natural
refineries where they are
gas
converted into
from
several
the earth,
products,
from the
including
soil,
the building blocks of plastic,
and
ethane from crude
refined
oil,
so we
and
can
propane
get
from natural
ethane
gas.
from crude oil
Ethane and propane
for
are then
natural
sent
gas.
to a cracker plant to be cracked or
After-
broken down into
after
smaller
we
molecules.
refine,
Ethane
we
produces
get-
ethylene,
we
and
get to the
propane
process
becomes
of
propylene.
cracking or breakdown.
Next,
Until we
a
get
catalyst
ethylene
is
and
mixed
propylene.
in, which links the molecules together and forms
After that,
polymers called
polymerization
resins.
and catalyst.
This structure
get
allows
resin.
plastics to be easily molded and shaped, especially under heat and pressure. Polymerization converts ethylene into the resin polyethylene and propylene into polypropylene. These resins are then melted, cooled down, and chopped up
The
into
resin
pre-production
we
plastic pellets
shape
known
into
as
a
nurdles.
tiny
Nurdles
little
are
ball,
later
so we
transported to
can
manufacturers
melt it
who
and
use heat to mold the
reshape.
nurdles into
4.6 Polymerization process. Step polymerization. It occurs by stepwise reaction between functional group of reactant. The reaction leads successfully from monomer to dimer, trimer, tetramer, pentamer, and so on until finally a polymer molecule with large dP is formed. The average molecular weight builds up slowly in the step polymerization process. Most of the step polymerization process involve polycondensation or repeated condensation reaction. Chain or addition polymerization. Chain polymerization involves three processes: chain initiation, chain propagation, chain termination. A fourth process, chain transfer, may also be involved. Benzoyl peroxide is a common free radical initiator and produce free radical by thermal decomposition as initiator and free radical. Copolymerization. Polymers can also be synthesized by the aforesaid process with more than one type of mer in the chain. Such polymers are called copolymers and are produced by polymerizing a mixture of monomers, copolymerization, or by special method. Copolymers can be of different types depending on the monomers used and the specific methods of synthesis that is employed. Three other copolymer structures are known. These are referred to as alternating block and graph to copolymer structure like figure 4.5. This is the table 4.2 typical addition of polymer. So this is the process of polymerization process. This is the example. The first one we need armamentarium. Polymer to monomer ratio should be 3:1 by volume. The first one we need to add monomer first, then polymer. This is monomer, this is polymer. Add it one by one. Texture is quite sticky, as we can see in the video. This is the next stage. The only stage when material is moldable, or we can one rubbery stage. As we can see, in this stage the polymerization it looks like a gum. Next stage or hard stage, and that's the last one. Next, structural shape of polymer molecules. Polymers can be classified on the basis of structural shape of polymer molecule as linear, branch, and cross-link. Linear polymers are those in which the repeating units are linked together in a continuous length, like figure 4.6a. This figure. There may be a long or short branch forming a comb-like structure like figure 4.6b, like this one. Or there may be branch like figure 4.6c, forming a dendrite-like structure. That's it for today. Thank you.